Welcome to this lecture. In the last lecture, we looked at the proxy pattern, very useful pattern, large number of applications. And now we will look at the decorator pattern. This is also a very important pattern, very powerful pattern. Many of the problems, if we solve using the decorator pattern, then the solution becomes really elegant. Without the decorator pattern, it would be very inefficient and bad solution. Let us look at the decorator pattern. The idea here is that we have many objects that have got created here. Now, during the run time, if necessary, we want to add additional responsibilities to these objects. But how is that possible? Because the responsibilities are basically methods, and a class has only fixed number of methods, right. So, once you create the object, the methods are fixed. How do we attach additional methods to an object dynamically? So far, we have only been familiar with attaching methods by subclassing, but then using subclassing, if we attach additional methods to a class, then they are bound to it permanently. But here our intention is that we want to attach some methods to some of the objects, and to other objects we want to attach other responsibilities. Clearly, this is a wrapper pattern. We want to add responsibility to objects, specific objects that we want. We do not want to add responsibility to all the objects of a class. That we know that by subclassing, we attach additional responsibilities to all the objects of the subclass. And here, once we attach the responsibility, it has it conforms to the same interface as the object. Let us say we want to attach some responsibility to the first object shown in the red, that is additional responsibility. We want to attach a different responsibility to this object shown in yellow, another responsibility to this object which is shown in green. We might also like to add the green responsibility to this object after some time, and so on. A very powerful concept. Let us see how it is done. The decorator, in simple words, is that you have an object, this is the object, and then you have another object which wraps around this object. That means, the wrapped object is the one which now becomes accessible to the user. The user cannot access this object anymore, because another object will wrap around this, and therefore, it interacts with the one that is on the outside, and that may pass on some method called to the object that is inside. Obviously, the method that wraps around on the object will have the same interface as the object itself. So, this green one has wrapped around the object. The clients can no more access the object, they have to use the green object because that is wrapping around this object. But then the client does not know really that the object has changed, because they have the same interface. It invokes the same methods on the green, and some of the methods, new methods, it answers by itself, it responds by itself. For the other old methods, the object, it passes on to the object, and therefore, the client of this class sees that some new capabilities of the object have materialized. We can even have more objects wrapping around this object. A red object has wrapped around here, the green is no more accessible directly, have to access the outermost object, the red. Whatever method, new methods it has, it will answer or respond for those methods. For the other ones, it will delegate it to the green in turn will answer some of that which has implemented, and the rest it will pass it on to the object. The ones on the outside, this is the actual object, and the green and red are the decorators. The client interacts with the outermost decorator, and the outermost decorator, it first tries to handle those methods which it can, and those methods which it does not implement, it passes on to the green, and the green, if it implements those methods, it will answer, otherwise it will pass on to the real object. Let us look at one example. Let us say you had opened an window on your desktop. This is a window, and then you wanted to resize. You are working on this window, you are seeing the listing and so on. Now, you want to resize it. To resize it, you pulled the corner here down, but then by pulling the corner, it has not only become smaller, but just see that there is a scroll bar which has got accessed, because now all the files are not visible, and therefore, mysteriously a scroll capability has come to the same window. How is it that the basic window that existed, now it has additional capability of scrolling? The full window, if you see, it did not have the scrolling capability. This is the full window. All the files were visible, and it did not have a scroll bar, but as you resized it, the files are not visible, and therefore, a scroll bar has appeared. How come the same window object during runtime has acquired additional capability of scrolling? This is a use of the decorator pattern. We will see exactly what happens, how it gets the additional responsibility using the decorator pattern. Before we look at the nitty-gritty of the decorator pattern, to better understand the pattern, that is the motivation for the pattern, how it simplifies and helps, and how without this pattern the application will become very complicated. Let us look at a non-software example which is easy to understand. Let us say you went to buy a gift. You went to the gift shop and selected the gift, and then you ask the shopkeeper to wrap the gift appropriately, but then you had several options. It can be wrapped up in several ways, maybe just a paper, maybe a paper with a tape, maybe with a bow, and so on. So, the different options, the gift wrap options that we look at, maybe the gift box is wrapped with only the gift paper, maybe it is wrapped with the gift paper and crepe paper, maybe it is wrapped with gift paper with bow, but without crepe paper. Maybe it is wrapped with gift paper with bow and then the crepe paper. Maybe it is without card, maybe it is with card, and so on. If we had all these as separate items in the shop, that the shop you have these cupboards, and in one cupboard we have only gift paper, another one where gift paper with crepe paper, another one cupboard with gift paper with crepe paper and bow, another one with gift paper, crepe paper and bow and card, another one is only gift paper, crepe paper and card, and so on. You will see that the shopkeeper will have to maintain at least 2 dozens of cupboard. No shopkeeper does that actually. It has one cupboard where it has the gift paper, another one where it has the bow, another one where it has the crepe paper. You can choose any one of them and then use it. They are not statically fixed. You have not really attached statically the bow to the gift paper and then the card and so on. That would have made the life of the shopkeeper and the customers very difficult, but we had this simple solution in the shop. If we did not have that simple solution, you would have different classes here. Let us say gift paper with crepe paper, bow and card, this is one class, and so on. These are statically attached, but we did not do this actually. This is inheritance. So, if you have this class here, so basically there will be many classes here, and these are basically the cupboards on the shop. If you look at this cupboard, this has card, bow, crepe paper and gift paper. So, this one is a gift paper with crepe paper and card. This is gift paper with bow and card. This is just gift paper and card, and so on. This is statically attaching the different capabilities. The class hierarchy can become extremely large if it was used in a shop. The number of cupboards will be extremely large, the customer will get confused, the shopkeeper will get confused. The shopkeeper, on the other hand, keeps the gift paper, crepe paper, bow and card in different cupboards, only 4 cupboards, and then as the customer says that what combination he needs and the order in which this need to be packed, he just selects them and puts them at run time. He does not statically create these and then maintain it in the cupboard. The idea behind the decorator pattern is something very similar. The shopkeeper just maintains the following cupboards, the boxes, the gift paper, card, bow and crepe paper, as the customer chooses the ones that he needs and the order in which these are needed. The shopkeeper picks one from these and then puts them in proper order in runtime. They are not statically attached. Selects the ones that needed and the order in which it is needed. The decorator pattern is very similar. Let us look at some examples. We had just seen that adding borders and scroll bars to GUI components, adding headers and footers to an advertisement. The advertisement object exists and then you might add any number of headers to that in the runtime, any number of footers. It is not that there are different classes. One is advertisement with one header, one footer, advertisement only header, advertisement without header, without footer, advertisement with no header, but 2 footers, and so on. Here we can dynamically add as many headers and footers needed to an advertisement. Add functionality to an input output stream. The Java I/O we have been using. The Java I/O profusely makes use of the decorator pattern. Here you can add capability to the basic stream class, for example, compressing. We will just look at it, that one of the largest uses of the decorator pattern is in the Java I/O. If we want to understand the Java I/O, we must understand the decorator pattern, then only it will make sense to us. Now, let us look at some general concepts. The decorator adds responsibility to objects. It is not subclassing. The subclassing will add responsibility to all objects of the class, but here we add responsibility to an object in runtime dynamically as and when it is required. The decorator pattern is indispensable when we need different capabilities to be added to different objects at runtime. As we had already seen that if we really wanted to do this without the decorator pattern and by using subclassing, there will be explosion of subclasses. Easily we will have thousands of subclasses to deal with, extremely confusing, difficult to remember and apply. And this is a right candidate to use the decorator pattern, will really simplify the application and make it elegant. Now, let us review the main idea. A decorator is an object that has the same interface as the object it contains. A decorator adds some functionality to an existing object or an object with some decorators. We will have an outermost decorator added, which will have some extra capability, and to that outermost we can add another outermost decorator, and so on. We have already seen that we can keep on adding decorators, and the client will interact with the outermost decorator, which will try to handle the method invocations by itself if possible, otherwise it will pass on to the next decorator. As a decorator, the outermost decorator gets the call, it relays to the object that it contains and adds its own functionality either before or after the call. The decorator pattern, if we are aware, we get tremendous flexibility while designing an application. We can change the decorator at runtime, we can remove a decorator, add decorators, maybe add the same decorator twice if necessary. We can add a different decorator, more decorators, remove some of the decorators as the run of the software proceeds. The decorator gets added in runtime as opposed to the static attachment of responsibilities that occurs by subclassing. The decorator has the same interface as the object it contains. So, the client objects, they do not even know that a decorator has come and taken place of the real object. Just like we saw the window, mysteriously additional capabilities appeared for the same object, but it is not the same object. There is a decorator which has come and sat on the real object. The decorator is indistinguishable from the real object, which contains the concrete instances, including the decorated objects. It is a very powerful technique and can be used to great advantage. Designers can recursively nest decorators without any other object being aware of this or being able to tell the difference, and allows significant customization. Now, let us look at the class diagram. Component is an interface. The concrete component is the one which existed. The decorator also implements the component interface. Okay, component can be abstract class or an interface. And there can be different types of decorators, concrete decorator A, decorator B, and so on. And see here that at any time one decorator gets added. On the decorated object, we can have other decorators get added one time at one. Requesting you to just compare this class diagram with the composite pattern class diagram. They appear very similar if you look at them, but then there is one small difference. I mean, functionally and so on, they are very different, their application is very different. I am just asking you to check the structural class diagram of the decorator pattern solution and the composite pattern solution, and just try to identify that one difference between this diagram and the composite pattern diagram. Now, let us look at an example application. Suppose you have a GUI component which has a text view. It contains text, and then you want to add different kinds of borders and scroll bars to it. Let us say you can choose between three types of borders: plain, 3D, and fancy. And scroll bars, either one scroll bar or two scroll bar, the horizontal and vertical scroll bar. And if you look at all possible combinations and provide this to solve this problem by using real classes, that is a plain border with horizontal, plain border with both horizontal and vertical, plain border with only vertical, 3D border with horizontal, 3D border with vertical, and so on. You will see that you require at least 15 classes. But when you can add the borders multiple times, let us say 2 plain borders or a plain border and a 3D border and so on, the number of classes, concrete classes, subclasses that you will have to create becomes real large, very large. Nobody would like to do that, and the application will become very difficult to manage, maintain, understand. we will have to use the decorator pattern, but how do we use the decorator pattern? What will be the class diagram? Let us look at the solution. Okay, these are the 15 classes, subclasses that you might have to use. If you wanted to statically attach this responsibility, the text view with just a plain border, text view with a fancy border, text view with a 3D border, text view with only horizontal scroll bar, vertical scroll bar, text view with horizontal and vertical scroll bar, text view with a plain border with horizontal scroll bar, and so on. These are 15. But if you wanted to allow repetition of some of the borders, maybe a plane with a 3D and also a scroll bar and so on, the number will be much large, and writing an application with that many classes to choose from, the programmer's life will be really difficult. But what we can do is use the decorator pattern. As we have already seen that the decorator forwards request to the component and performs additional responsibility. So, the solution will look something like this, that we have visual component and then we have a decorator, border, scroll bar, plain, 3D, fancy, horizontal, vertical, and here text view, and we also have a streamed video view. The other problem we did not have. If we had a streamed video view in the other problem, then the count 15 will have to be increased tremendously. So, here both text view, streamed video, and we can add all these border and scroll bar, any number of them dynamically. It is a very powerful pattern. We will look at more examples, so that we become real familiar in applying this pattern to real problems. We are almost at the end of this lecture. We will stop here and continue in the next lecture, where we will discuss about the decorator pattern with more examples and also the Java code. Thank you.